These sections of the A380's outer skin are made from a composite of two materials. Like the buffalo horn in the Mongol bow, lightweight aluminium provides stiffness. But with a heavy impact, it will bend, then rupture completely. It needs a second material, like the sinew in the Mongol bow, to give it added strength. And Paul Hogg has given me an amazing suggestion. Glass. An ordinary sheet of glass is very brittle. It looks perfectly clear, but it's actually riddled with microscopic cracks. The sudden impact makes the cracks ripple through the whole sheet. You can't build a plane out of that. But as I'm about to find out, there's a way to make glass strong enough to survive a bomb explosion. The outer skin of the world's biggest airliner, the Airbus A380, must be super light and super strong. In the A380, the first material is lightweight aluminium. But the second material must be incredibly strong to withstand high-speed impacts.
Ooh, look at that.
So materials engineer Paul Hogg is about to show me a very special form of glass.
So I just put that in there, yeah?
Yeah, put it in the flame. Sort of, so move it back towards the point of the flame. Keep rotating it to distribute the heat. You'll feel it begin to go soft and a bit sort of floppy.
Let's go and bendy.
Let's go now.
Okay. Wow! Wow! We're still connected. Look at that! We are still connected. You may not be able to see it, but we are still connected by glass. That's.
There you go. There we go.
This is just glass.
It's just glass.
So this is pure, ordinary glass that we've just coiled up again.
Yeah.
Why is this doing this?
It's thinner and therefore more flexible, but it hasn't got the defects and cracks on the surface, which is why you can coil it quite nicely without it snapping.
This is a glass fibre, and it's very different to ordinary glass. With no cracks, it's incredibly strong.
It's about 6 to 10 times the strength of steel.
If this was steel wire or something, this
would carry about 6 to 10 times as much weight as the steel wire would.
I'm mesmerised by this stuff.
These glass fibres can be woven like textiles to produce sheets of material. The next stage is to add liquid resin. When it dries, it sticks the fibres together to create glass in its strongest form. Fiberglass. Let's see if this window can be smashed.
Hey, hammer. So I'll just hit it. That would have done the glass, wouldn't it?
I think it would have done. Try it again. Don't be shy. Give it a good welly.
Glass fibres provide the strength. The individual fibres might break, but the cracks can't spread from one to another.
It's quite surprisingly tough, isn't it?
It is.
And fiberglass is even tougher when combined in a composite with aluminium.
Google Richard Hammond's Airbus A380 engineering connections to see more detail on this incredible concept, which is actually what's happening when we get insulted, hurt, and we contain ourselves. That allows the heat of the pain to melt out any tiny fractures and give us superpowers that normally are not available. And those superpowers, as you saw in the video, give you the ability to protect the effects of an explosive bomb. It's an incredible concept. So from victim to hero, try it on. Feel how good it is to imagine in your mind that every drop of your pain is saving 1,000 times more pain in other people that you care about. Your brothers and sisters, the Jewish people. And most important, the Almighty. The Almighty feels every drop of pain. We're saving the Almighty from pain. A person who considers the Almighty's pain doubles the power of his schar, his schus, and his ability to protect.
The impact
Okay, I've come down to the business end of our little chicken firing range here because I really want to see what happens when the chicken hits the glare. Does it bend? Does it come back? I want to see how it behaves.
You ready, Richard?
Yeah, I think so. You're
Okay.
on time.
3, 2, 1.
Oh, well, it's not very nice being that close to a very fast chicken, but it's resisted it. It hasn't gone through.
There's a dent, but the glare survives.
It does work. The two materials working together are better than either alone.
That's fantastic, isn't
Yeah.
it?
For the A380's designers, glare is the perfect combination of high strength and low weight, vital for an airliner this size. It's 25% lighter than aluminium, one reason why the world's biggest airliner has better fuel consumption per passenger than a family car.